One of the easiest and funniest things to do in Unity is to create physics-based simulations. In the Brackeys video How many rigid bodies can Unity support? It tries to find the best way to achieve a smooth simulation while having as many rigid bodies as possible. The conclusion is that none of the graphical or rigid body settings improve the frame rate, but enabling adaptive force in the physics settings and reducing the time step of the physics calculations help a little bit. Do not reduce it too much though, because it will be laggy again. Of course, building the game also greatly improves the simulation. It ended up with a smooth 60 FPS simulations of 6000 cubes with a small drop to 40 FPS toward the very end. As these numbers are completely dependent on the specifications of the Brackeys computer at the time, let's recreate the same scene on my PC to find my maximal rigid body limit before switching to the dots physics. First, let's create a new project. Be sure to use Unity 2019.3 or later to access the dot packages. Once loaded, simply add a floor plane and set its X and Z scale value to 50 so that it's large enough to carry thousands of cubes. And we can create a light grey material for it. Next, simply add a cube with a rigid body component and create a material for it as well. You can choose the color you want. I picked light blue. Also, I'm just gonna set the light to be auto-generated in the lighting settings so it will look much nicer. And now we can duplicate the cube several times with Ctrl D, place them around and create a simple structure. And that's it! Hit the play button and voila! Everything runs smoothly because there are not many cubes yet. So let's add more of them. I only kept one cube and made it a prefab so we can remove it from the scene. And I also added an empty game object called Tower Creator with a small script to help us create a cube tower faster. It needs to contain a public game object for our cube prefab reference, which we will use to spawn the cubes, and 3 ints for the size of our tower. The script will create a grid of cubes of the size length times width. To do that, we need 2 loops, looping over width and length, and simply instantiating a cube at the position of the current length L and the current width W. With a Y of 0.5, this is because our cube is of scale 1 and the default height for it to be on the floor is 0.5. In fact, we don't want our tower to be filled with cubes. We only want a border of them. This means that we only need to instantiate cubes on the first and last rows, and the same for columns. We can therefore check if our current length or width values are not equal to 0 and also not equal to their maximum values, and if so, simply do nothing. Now we just need one more loop. This one will be for the height. We are simply going to repeat our first instructions as many times as our height, so we just have to warp our loops inside the new one, iterating over the height values. We still have to determine how smooth our game is running by measuring its frame rate per second. A good FPS target is 60, and this means that the game will have to render 60 frames within 1 second, leaving only 16.67 milliseconds for each frame. And we can actually check how long each frame takes in the profiler window. Here we can select a frame in the timeline and see exactly the time taken by each operations. In our case, when the number of cubes is high enough, the physics fix update operation takes almost all the time to render the frame. This is because our game has to compute each physical interaction of each rigid body that we have in our scene. And we have a lot of them. So let's find out our maximal rigid bodies limit now. We will need to track our FPS so we can get the light FPS counter available for free on the asset store, RIP mini profiler, and to use it, simply drag and drop the prefab that come along the package. I have just increased the font size a little bit to make it more readable, and we will also need a cube contour text to display our number of cubes. So let's add one in our canvas, and open our tower generator script again to add a reference to it. We just need to declare an int and increment it every time we instantiate a cube, and at the end of our loops, update the cube count text with its value. Awesome, now we can test different values and build a game to find our limits. I've reached mine at 8500 cubes. Now that we reach our limit with the default physics engine, let's see if we can improve this number using Unity's new high-performance, multi-threaded, data-oriented technology stack, or DOTS for short. DOTS is a collection of packages including the Entity Component System, the C# Job System, and the Burst Compiler that take full advantage of today's multi-core processors and deliver much more optimized games. The dots package that we are looking for right now is the brand new physics engine. It will enable us to create huge physics simulations that deliver exceptional performance. It leverages the burst compiler and job system to make physics calculations more performant. So back to our scene again, let's import the Unity physics package to use the new physics engine. The Unity physics package comes with the most important dots packages as dependencies, so we don't have to install each of them manually. Awesome, now we have access to some cool new features. The first one we are going to use is the GameObject-to-Entity Converter component. This is a script that converts a game object to an entity, and we need to have entities to use the new physics engine. So let's attach it to our cube prefab, but now we also have to replace our Rigidbody component by the new PhysicBody component, and our box collider with the physics shape component. By default, the box shapes come with a small bevel at the borders, but it can increase the complexity of the collations, so we want to set it to 0 to have simpler shapes. We also have to convert the floor to an entity with a physics shape, so it can collide with our cubes, because the two physics engines are not able to interact with each other. Alright, now we can test our new cube entity by placing it in the scene, and you see now that when we play the game, our cube game object disappears from the hierarchy. That is because it has been converted to an entity. And to see our current entities, we have to open the entity debugger. Here we can see that we have two entities, one for the cube and one for the floor. Awesome, now our cube is converted to a physics-based entity and stay on our floor. Let's update our tower creator code to spawn a tower of cube entities and unleash the power of dots. And for that, we need to convert our cube prefab to an entity within the code, and there are some boilerplate code to do this, so just follow me on this one. But eventually we end up with an entity and just keep in mind that this code may change in the future with the next versions of dots, as these packages are still in preview. But once we have it, all we have to do is to replace the instantiate line with an entity manager.instantiate cube entity. And the way to set the entity position is a bit different for our traditional game object. We have to create a translation component that takes a value of type float3 and then tell our entity manager to set it to our entity instance. If it seems complicated, just think of it as setting the transform position vector 3 value of a regular game object. We just have to add one more line on the onDisable function to avoid any errors. And that is it! Our script is now spawning much more optimized cubes entities using the new physics engine. So let's put Unity to the test again to find our new limits. After some tests, I've reached my PC limits with more than 15,000 cubes while recording the screen to keep an average of 60 FPS. But I also found out that I could get much higher numbers without completely breaking Unity, so I recorded a 50,000 cubes simulation with an average of 15 FPS. As we've seen, the new dot features are definitely promising, and I can't wait for them to be out of preview. One of the coolest features will be the dots editor that is currently in a very early stage, but will make the work with entities much more easier in the future. And that's it for this video. If you like it, don't forget to like the video and subscribe to the channel so you will not miss the next one. Also, post a comment on what you want to see in the future and leave me feedbacks because it's my very first video in English and on Unity. Have a wonderful day!